Hello Year 10 and a Happy New Year. Welcome back to our slightly unusual start to the new term. So this video is just going to go through and consolidate our work on series circuits that we were looking at before Christmas. And we're just going to do a little bit of consolidation work on that following the presentation that I've put together as well. So I'm going to draw on under the visualizer here some of the stuff I'd like you to kind of add into your notes and work on as we go through this. So I'm just going to draw first of all a simple series circuit for us. And I'd like you don't need to write anything for the moment, okay, or draw anything. Just have a look at what I'm doing. So we've got our cell, our battery, we've got an ammeter, another ammeter, and we've got our two resistors. And all I want you to do for me first of all is tell me what is the likely current flowing through this circuit if I give you certain bits of information. So if I tell you that the ammeter reading of ammeter number 1 is 1.5 amps, I want you to predict and write down what you think the reading would be in ammeter 2. Okay, what you should have said is that it will be 1.5 amps. Let me try that again. If the reading in ammeter 1 is 2.5 amps, what do you think the reading in ammeter 2 will be? Yep, that's correct. It is 2.5 amps, because if we recall, the first rule of series circuits is the current is the same no matter where that ammeter is placed. So at different points around the circuit, the current remains the same. So our first point is that current is the same at any point in a circuit. Okay, so there's our first bit of information. Let's look at another circuit now. If I tell you that the reading in ammeter 2 is 3 amps, what would you expect the reading in ammeter 1 and ammeter 3 to be? Now, of course, what we should say is that still doesn't matter whether we have 1, 2, 3 ammeters, and it still doesn't matter where they are. Our reading will still be 3 amps and 3 amps. Okay, so that's what you should have put. Okay, so what I'd like you to do is to draw this circuit, okay, as I've drawn it here, without the 3 amps, okay. And I'd like you to do the same thing and show me what the readings would be as follows. Okay, so number 1, if ammeter 2 reads 1.8 amp, what do ammeter 1 and ammeter 3 read? Part 2, if ammeter 3 reads 2.0 amps, we'll do A1 and A2 read, and finally if the current through the cell is 0.8 amps, what do A1, A2 and A3 read? Okay, so those are the three questions I'd like you to answer in your book after drawing that diagram. Pause the video here and give yourself a chance to have a go at that. Okay, and what you should have said, of course, is that this is your drawing. Okay. Number one, we should have said it is. This pen's not very good. I'm going to use a darker pen. Apologies. 1.8. Number two, 2.0, and number three. Even though it's looking at the cell, again the current is still the same. So we're still saying that it's 0.8 amps throughout. Okay. Okay, so that looks at series circuits and looking at current in series circuits. We're now going to look at potential difference. Okay, so looking at potential difference. So let's look at it at an example first of all. Okay. Here's my circuit. I'm going to look at a circuit with excuse me, two resistors. Now remember, if we're looking at potential difference, we measure the potential difference across the circuit. So our voltmeter goes across the component that we're interested in. Okay, I'm going to call this V1 and V2. Remember our ammeters went in series, our voltmeters go in parallel. Now, our potential difference across our cell between from one end to the other end of our cell is 6 volts. Okay. Now, what I know is that therefore the total potential difference around my circuit is 6 volts. What I don't know is how much is going across each of these resistors. They may be the same, they may not be the same. What I've been told is that V1 has a potential difference of 2 volts. And I'm asked to find out what is V2. Now, if there is 6 volts in total flowing across my circuit, and 2 volts of that is across V1, the remaining voltage, the remaining potential difference must be across resistor 2, or V2. So V2 simply equals 6 volts minus 2 volts, which equals 4 volts. Okay? What if V1 here equaled 3 volts? V2 again would equal 6 volts minus 3 volts this time, so V2 would equal 3 volts. What about if V2 equaled 1.5 volts? Well, this time we're finding out V1. Okay, we know that again it's still 6 volts minus 1.5 volts. So V1 this time would equal 4.5 volts. Okay. we can also look at this a slightly different way. Okay, we can also ask, well, that's all very well, but what if I don't know the voltage of my back cell? I know that V1 equals 4 volts, and I know that V2 equals 5 volts. Well then, okay, the cell equals V1 plus V2, which equals 9 volts in this case. Okay, so fairly straightforward. So what I'd like you to do now, okay, is to, similar to what we've just done, I'd like you to draw the following circuit and answer the questions that I'm going to give you. Okay. So we have a circuit with 3 resistors. Okay. Now remember, we're using resistors. This could be any component. This could be a bulb or anything like that. Okay. The potential difference across the cell is 9 volts. Okay. We have a voltmeter V1 attached across this resistor, and we have another voltmeter V2 attached across the third resistor. Okay, so I'd like you to draw this circuit. And I'd like you to answer the following question. If the potential difference, I'm going to abbreviate to PD, across V1 here, is 2 volts, and the PD across V2 is 4 volts, what is the potential difference across the middle resistor? Because we don't have a voltmeter on that, so we don't know. Okay, so pause the video and have a go at that task. Now, you should, of course, have worked out that the total is 9 volts. Okay, so V1 plus V2 equals 2 plus 4, which equals 6 volts. 9 volts across the cell minus 6 volts equals 3 volts across the middle resistor. Okay, so hopefully that made sense to you. Okay, now the last thing we're going to look at for this is resistance in series circuits. Okay. Resistance in series circuits. Now, you have done a little bit about this already, but we're going to kind of look at this in a bit more detail. Okay, so here's my circuit again. Okay, this time I'm going to start off with 2 resistors in series. Okay, now remember, we're not interested now at the moment in terms of current or potential difference. We just want to know how much is the resistance across each of these resistors. Now we're going to start off with 2 resistors that are exactly the same. They both have the same resistance, 2 ohms across both. Okay. Now to find out our total resistance, we are simply going to look at resistance 1 plus resistance 2. So our total resistance in series is 2 plus 2, which is 4 ohms. Okay. Let's change this slightly. make one of the resistors 12 ohms. This time we've got 12 plus 2, so we've got 14 ohms of resistance. Okay. Now, what about if I didn't know what this value was, but I knew that my total resistance, okay, equals 20 ohms. I've measured the total resistance across the circuit is 20 ohms, and I know that R1 is 12 ohms. Okay, so therefore, what I can do is simply 20 minus 12, so R total minus R1, R2, so therefore R2 is going to equal 8 ohms. Now we can also calculate resistance, okay, now using our voltage or our potential difference and our current. So I'm just going to kind of introduce that right now, okay. So we use the equation that we've mentioned before, V equals I times R, where V is our potential difference, I is our current, and R is our resistance. Okay, so let's have a go at this. I'm going to give you a question that I'd like you to have a go at. Calculate the total resistance if the potential difference is 6 volts and the current is 3 amps. So pause the video, have a go at rearranging the equation and see how you get on. Okay, how did you do? Now, you should have said this. First of all, we supplement our numbers. Then we rearrange our equation to find out R, which equals 6 divided by 3. So we have a resistance of 2 ohms. Okay? So I'm going to give you one more task to do for this. I'm going to ask you to again draw a circuit. It's similar to the one I've just used. 2 resistors in series. Okay. A resistance on R1 of 5 ohms. So I'd like you to draw this, and then I'd like you to answer the following question. Okay, 2 questions in fact. So number 1, if total resistance is 20 ohms, what is the resistance across R2? And then if voltage stroke PD is 6 volts and current is 0.3 amps, show that, we don't need to calculate it because I've already told you what it is, but I want you to show me that total resistance is 20 ohms using that equation. Okay, so pause the video and have a go at that. Okay, how did you get on? So hopefully you've drawn the circuit as I showed you, but number one, you should have said that because total resistance equals 20 and the first resistor R1 equals 5, therefore 20 minus 5 equals 15, so R2 equals 15 ohms. And then the second question, we're just going to use that equation, V equals I times R. I said that V is 6, I is 0.3 times R. So to find R, we would do 6 divided by 0.3, which equals 20 ohms, and shows us and confirms what we said was correct. Okay, so that's all on the video. Now what I'm going to do is I'm also going to set you a couple of problems to try and work through yourself after you've been through these tasks. Okay, so that's it for this video. Next lesson we will look at parallel circuits. Okay, good luck. Any questions, please do let me know.